Hello everyone. Today we are talking about basic energy concept. As you can see on the screen, our content is for today. Definitions and types of energy, alternating and direct current energy, cable and complementary methods. Let's start the basic concept and types of energy. Energy is the capacity that allows a system to work or to change its state. It can take different forms, such as mechanical, electrical, thermal, or chemical energy. Energy sources are the different types of resources from which energy is produced. There is a wide range of energy sources, which can be grouped as follows. Fossil fuels, coal, oil, natural gas. Nuclear energy, renewable energy sources, solar energy, wind energy, hydropower, biomass, geothermal energy. Other energy sources, hydrogen, waste to energy. According to the process of energy conversion is the transformation of energy from one form to another. For example, electrical energy is converted into heat energy in a heat radiator. Energy efficiency refers to how efficiently energy is used. The lower the energy loss of a process, the higher its energy efficiency. Energy consumption is the total amount of energy used by a system, e.g., a country, a company, or a household, over a given period of time. Energy consumption is the use of energy from energy sources by an individual, company, or country. Energy consumption occurs in many areas and takes many forms, from people's daily activities to industrial processes and transport. You can see the areas of energy consumption, which includes 1. Household energy consumption. Household energy consumption includes energy used in residential buildings, household appliances, and lighting. This includes cooling, heating, lighting, use of household appliances, etc. 2. Industrial energy consumption. Industrial energy consumption refers to the production and use of energy in industrial facilities, factories, and plants. It includes energy demand for machinery, equipment, temperature control, and lighting. 3. Transport energy consumption. Transport energy consumption refers to energy use associated with the operation of cars, planes, trains, ships, etc. It includes fuel consumption and electricity supply of vehicles. 4. Commercial and institutional energy consumption. Commercial and institutional energy consumption is energy used in commercial buildings, office buildings, shopping malls, schools, hospitals, and other institutions. Really significant fact is that the scale and composition of energy consumption can vary significantly across countries, regions, and sectors. Effective management and reduction of energy consumption is important for sustainable development and environmental sustainability. Energy-saving measures, energy-efficient technologies, the use of renewable energy sources, and the conscious use of energy all contribute to reducing energy consumption and to more sustainable energy management. It is important to clarify and highlight the definition of energy supply, which means the supply of energy to consumers. It includes the generation, distribution, and transport of energy. The process of sustainability is a challenge for all of us. Sustainable energy means energy sources that are sustainable in the long term, do not deplete natural resources, and are produced in an environmentally friendly way. Sustainability and environmental protection are a priority for humanity today. To do this, we need a change of lifestyle. For example, we must strive to reduce carbon dioxide emissions. Carbon dioxide emissions measure the emission of carbon dioxide, CO2, gas, which is often found in combustion products. Carbon dioxide emissions contribute to the increase in greenhouse gas concentrations and the problem of climate change. Let's continue with the next subtopic in today's lesson: alternating current, AC, and direct current, DC. Alternating current, AC, and direct current, DC, are two basic types of electrical power transmission. They operate in different ways and are used in different applications. The characteristic of AC is that the current direction and current intensity vary periodically in time. In AC circuits, the direction of the current changes continuously, usually in the form of a sine wave. AC current has a wide range of applications and is commonly used as mains electricity in homes, businesses, and industry. AC current enables a power converter, which allows the current to be transmitted at high voltage and then converted to a lower voltage at the consumer. The figure shows the variation of the AC current value with time. The voltage also varies accordingly. It can be clearly seen that this changes periodically, according to the sine function. During a period, the current reaches its maximum value, then changes direction and increases in the negative direction to a maximum. The figure also shows that during a period, current is 0 in 2 time instants during a period. At the frequency of the alternating current is the number of complete periods in 1 second, expressed in Hertz. Benefits and applications for AC current are long-distance power delivery. AC power allows efficient power delivery over long distances. High-voltage AC power can be converted in an easier and more efficient way, thus reducing energy losses over long distances. Grid electricity. Electricity used in homes, businesses, and industry is usually AC. AC power is readily available from the utility grid. High-power applications. AC power allows high-power devices such as industrial machines, air conditioners, electric motors to operate efficiently. It is important to note that AC and DC both have advantages and applications. AC current allows for remote power delivery and easier voltage conversion, while DC current provides easier control and storage in certain applications. Both types play an important role in power supply and electronic devices. Continue with direct current, DC. DC current is characterized by the fact that the direction of current and the current intensity remain constant. In DC circuits, the direction of the current does not change and it usually flows at a constant voltage and current. DC current is most often supplied by batteries, accumulators, or special power supplies. DC is used in devices with specific needs, such as computers, electronic equipment, electric vehicles. The figure on the left shows the time diagram of the unchanging, pure, direct current. This current value is constant in time, so it is the same at all time points and flows in one direction. It is usually produced by batteries. On the right is the time waveform of the AC mains current, which we discussed earlier. Benefits and applications for DC current are electronic devices. Converters and power supplies provide DC power to these devices. DC power can be easily stored in batteries or accumulators. This allows portable electronics, electric vehicles, solar systems, etc. to operate. Special applications. DC is the appropriate power source for certain industrial processes, medical equipment and laboratory devices, such as electrochemically controlled processes or precision measurements. It is important to understand that AC and DC current types interact with each other in the generation, distribution, and use of energy. Often, power is generated in AC circuits and then converted to DC to meet consumer needs in various applications. The third and final subtopic in today's lesson is cables and accessories. First of all, let's define the word cable. The term cable generally refers to wiring for the transmission of electricity. Electrical cables play an important role in the transmission of power, the communication of data, and the connection of electronic devices. However, the term complementary methods can be broader and can refer to various devices or techniques used in connection with cables or their use. As the pictures show, our first group is electrical cables and charging cables. Wires used for the transmission of electric current, in which alternating or direct current is transmitted. Electrical cables may contain multiple conductors, current protective sheathing, and insulation for safety and efficiency. A special type of electric cable is the charging cable used to charge electric cars, which consists of a cross-section of conductors sized according to the nominal charging current. The cable, integrated with the connectors, provides safe charging. The next ones are data cables. Data cables are used to transfer data or signals, for example for communication between computers, network connections, or audio-video connections. Examples of data cables are Ethernet cables, USB cables, HDMI cables, etc. The following picture shows a coaxial cable. In coaxial cables, a central conductor and an outer layer form the signal transmission and are often used for audio, video, or RF, radio frequency, applications. At last but not least, the optical cables are next. Optical fiber cables embed optical materials, usually fiberglass or plastic fibers, that allow high-speed transmission of data in the form of light pulses. Applications for optical cables include optical data transmission, telecommunications, television broadcasting, and medical imaging systems. To fully understand this topic, we need to talk about the different connectors and accessories. Cables are often equipped with various connectors, plugs, or connecting cables that allow the cables to be connected or connected to other devices. Examples of connectors and accessories are USB connectors, audio jacks, RCA plugs, BNC connectors, etc. In power and electronics, there are many different connectors and accessories that help to connect devices and systems and provide functionality and compatibility. First one about the electrical connections. The types of electrical connectors permitted by the standard depend on the voltage level used, the type, the current drawn by the equipment to be used, and the contact protection class of the equipment. This picture shows single-phase and three-phase electrical connectors. On with the audio and video connectors. RCA connectors. These connectors are often used to connect audio and video devices such as televisions, DVD players, speakers, etc. HDMI connectors. These are digital audio and video connectors for high-definition TVs, monitors, and other devices. XLR connectors. These are professional audio connectors often used in audio engineering, for microphones, amplifiers, etc. We can use data communication connectors such as USB connectors. These cables and connectors are widely used to transfer data and connect devices such as computers, printers, mobile phones, etc. Ethernet connectors, RJ45. These connectors are used in network communications, e.g., to connect computers, routers, switches. The last item on our list today is optical connectors. SC, LC, ST, or FC connectors. These optical connectors are used for connecting optical cables and high-speed data transmission in optical networks. In conclusion, just a few thoughts on plug adapters and converters. Connector adapters and converters. These devices allow compatibility and interconnection between different connector types. Connector sockets and plugs. These accessories allow wall or desktop connection of connectors. Today's lesson is based on the references and resources listed here. As we come to the end of our lesson, I would like to thank you for your attention and wish you a good learning experience.